Hello, welcome to this lesson in calculus limits. Here we're going to continue solving limits, but as I told you several times, the very simple limits with very well-behaved functions are very easy because either you make a table or you just plug in the value and get the limit. But then eventually you get to functions that are not quite so easy to understand. So let's do that now, but you'll find out that once you understand what to look for, it's not very hard either. So let's study a limit that's a little bit harder to just simply evaluate like we've been doing before. Let's say the limit as x approaches 1 of the function x minus 1 over x squared minus 1. So this is a function here. Now I'm going to tell you right now to be careful of functions that are something on the top divided by something on the bottom. Those are called rational functions or rational expressions. The word rational just means it can be written like a fraction. In fact, the same thing applies to regular fractions. The fraction 1/2 is a rational number because it can be written as a fraction. The fraction 3/5 is rational because it can be written as a fraction. Pi, for instance, is not rational because you cannot write that as a fraction. So that's kind of an aside, but this is a function and we use the same word. We call it rational because it can be written as a fraction, which in fact it is, just written on the board like a fraction. So I'm going to tell you right now, anytime you're doing a limit of one of these rational guys, you got to be careful because the first thing you should do when you evaluate limits nowadays is just try to plug it in and see what you get. See if you get something weird. And I know I'm being a little bit vague when I say see if you find something weird. But as you do more practice with problems, you'll figure out what to look for that will tell you that you're running into problems. So if we try to plug this in, we try first to plug in. What's going to happen if you put this in here is you're going to get 1 minus 1 on the top, and this is a 1 because 1 squared. You'll have 1 minus 1 on the bottom, so you'll get 0 over 0 here, right? What does 0 over 0 mean to you? Okay, clearly it's not a limit. We're not approaching a number, right? So, or at least it doesn't appear. So you might circle 0 over 0, and you might say, well, that's it. I don't know what else to do. Well, we're going to show you that the answer really isn't 0 over 0. When you get something like this, basically it's undefined. You can't proceed just by straight plugging in when you get an odd answer like that. So that's my advice to you. When you see a limit, just try to plug in the value and see what you get. If you get something weird or undefined like that, then you have to stop and go to another way of solving the problem and see what you can find. And so the next step along the road of solving this problem, since we ran into a roadblock here, is we always go back to writing our nice table. So here we have f of x is x minus 1 over x squared minus 1. And then here we have a nice table like this. Now we're approaching the number 1, so let's start out plugging in a value of 0 here. If we plug in a value of 0 here, 0 minus 1 gives us negative 1. This will again be 0 minus 1 gives us negative 1. So we just get a value of 1. Okay? Now let's make x get closer and closer to 1 because that's what we're trying to do, so let's just get a little bit closer. 0.75. I'm not going to do all the math, but when you go through here and subtract and then you square it and subtract and you divide, you get 0.5714. And if you get a little bit closer, let's do it like this, 0.95, that's what I was trying to write, you'll get 0.5128. If you get a little bit closer, 0.99, you get 0.5025. And if you get 0.9999, super close to the value of 1, you'll get 0.50003. Now, what do you see in this pattern here? Okay, as soon as we get even kind of close, we already start getting close to 0.5, and then as we get closer and closer and closer, basically all the digits get pushed out, and we get very, very close to the value of 1/2. So basically this approaches 1/2. So